need to inspect what prompts your MCP server actually exposes before using them. We'll see how to list all available prompts with their arguments and metadata, then filter them by tags to find exactly what you need. The pattern uses FastMCP's list prompts to retrieve reusable message templates, including custom tags stored in the FastMCP namespace.
Async with client. Prompts equals await client list prompts. Hash prompts list MCP. Types prompt. For prompt in prompts. Printf prompt, prompt name. Printf description, prompt description. If prompt arguments. Printf arguments. Arg, name for arg and prompt arguments. Hash access tags, and other metadata. If hassetter, prompt meta and prompt meta. FastMCP meta equals prompt, meta get FastMCP. Printf tags, FastMCP meta get tags.
This demonstrates the metadata-driven discovery pattern for working with reusable AI prompt templates. The code shows how FastMCP treats prompts as first-class components with self-describing metadata, including names, descriptions, arguments, and custom tags. What makes this distinctive is the separation between prompt definition on the server and prompt usage by clients, enabling dynamic discovery without tight coupling. The pattern works through declarative metadata that travels alongside the prompt implementation. Servers expose prompts with structured attributes, while clients dynamically query and filter them using standard operations like list prompts. The meta field acts as an extensibility point, allowing custom metadata, like FastMCP's tags, to coexist with standard MCP attributes without breaking compatibility. This creates a clean contract where clients can discover capabilities at runtime rather than requiring hard-coded knowledge. This approach solves the problem of prompt management at scale, where you need to maintain dozens or hundreds of reusable templates across multiple servers. By treating prompts as discoverable resources with rich metadata, teams can build modular AI systems where components remain loosely coupled. The trade-off is slightly more complex initial setup for metadata, but the payoff comes in maintainability. Adding new prompts or modifying existing ones doesn't require client-side changes. It's particularly valuable in multi-tenant or plugin-based architectures, where the set of available prompts may evolve independently of client applications. Let's break it down line by line.
Async with client.
Async context manager pattern ensures the FastMCP client connection is properly initialized and cleaned up, even if an error occurs during operations. Handles resource management automatically when the block exits.
Prompts equals await client list prompts.
This fetches all available prompts from the FastMCP server asynchronously. The await handles the async operation, returning a list of prompt objects that define the AI callable tools and their schemas.
Hash prompts list MCP. Types prompt. For prompt in prompts.
This iterates through the list of available prompts returned by the FastMCP server. Each prompt object contains metadata like name, description, and arguments that define how AI models can call it, forming the core interface between your code and AI tools.
Printf prompt, prompt name.
This prints the prompt's name from the prompt object. The name serves as the human-readable identifier for each prompt, essential for debugging and user-facing interfaces.
Printf description, prompt description.
Outputs the prompt's description to the console, providing human-readable context about what the prompt does. This helps developers quickly understand each prompt's purpose when listing available options, especially important in CLI tools where metadata isn't visually apparent.
If prompt arguments.
This is a defensive check against none-empty collections. It prevents attribute error when accessing prompt arguments since not all prompts require parameters. Common pattern when working with optional nested data.
Printf arguments. Arg, name for arg and prompt arguments.
This extracts argument names from the prompt schema using a list comprehension. It provides a quick overview of what parameters the AI tool accepts, critical for debugging and documentation. The pattern efficiently transforms a collection of argument objects into a simple list of names.
Hash access tags and other metadata. If hassetter, prompt meta and prompt meta.
This is defensive metadata access. The hassetter check prevents attribute error if meta doesn't exist, while the truthy check handles cases where meta exists but is none or empty. This pattern safely navigates optional nested data without crashing.
FastMCP equals prompt meta get FastMCP.
This safely accesses FastMCP specific metadata through the meta dictionary, using get with a default empty dict to prevent key errors if the fast key doesn't exist. The pattern handles missing metadata gracefully, ensuring the code won't fail when processing prompts without FastMCP extensions.
Printf tags. FastMCP meta get tags.
This safely accesses the tags array from FastMCP's metadata, using get with a default empty list to prevent key error if tags doesn't exist. The pattern handles missing metadata gracefully, ensuring the code never fails on optional fields. Prompt discovery pattern. The list prompts method reveals FastMCP's server-side template system, where reusable message structures become first-class citizens in your AI workflows. Metadata lives in the FastMCP namespace, not at the root level, so always check for its existence before accessing tags or custom fields. This approach transforms static prompts into dynamic, discoverable components without changing their core behavior.
The prompt that describes itself needs no description.